Dear students, welcome to ACE Academy and ACE online platform. This session is dedicated for discussion of previous year questions from the subject engineering mechanics before 2000 year. So here is the first question. A and B are the endpoints of the diameter of disk rolling along the straight line with a counterclockwise angular velocity omega as shown in figure. Referring to velocity vectors at VA and VB shown in figure is dash. So VA and VB, we are finding it as tangential to the disk, and here it is a rolling. So if it is a rolling case, then the rolling is combination of translation and rotation. So these velocities are actually tangential to the surface. The velocity which is responsible for translation is ignored. So translation velocity will be horizontal, and it will be horizontal over here as well. So now the resultant velocity of these two is expected to be somewhere here. Okay, and this would be the velocity VB or resultant of VB. Okay, so it is a rolling motion, so only they have included the tangential velocities or velocities which indicate only rotation part. Translation is not indicated. So hence both the vectors VA and VB, the marking of that vectors is incorrect. Okay, so actually the VA vector should be indicated in the green color, and this is the vector VB. So or else you can do one thing, you can also go with the I center for pure rolling motion, that is point of contact, and from this point of contact join the point A and join the point E. So to this line draw a perpendicular vector, Okay, so here you are finding that VB was tangential, but actually VB is not tangential, it is intersecting the circle, and here VA is like this. Okay, hence the direction of both are incorrect. So option C is the answer. Either you could use I center method, or you could add the translation component of the velocity, which was missed. Moving to next question, the I center method, the I center for a body rolling with sliding on a stationary curved surface lies on. So I center for a body which is rolling and it is sliding on a stationary curved surface. So it is going to lie at the point of contact, and option B says that on the common normal at the point of contact. So here the I center, it is rolling. Rolling means it is going to form a higher pair. So for higher pair, the I center will always be on the common normal. Understand that. I center will be on the common normal. Okay. And here, along with that, they have given the word sliding. So if it is sliding, it will be on the common normal, but at the point of contact, it could be above the point of contact or below the point of contact. So option A says that point of contact, option B says that on the common normal, point of contact, which is half correct and half may not be correct. Option C says that on the common tangent, this is totally discarded because I center will lie on the common normal. And option D says that at the center of curvature of the stationary surface. So this is for the curvilinear motion. Option A is applicable for curvilinear motion, not for the rolling motion. So here it is saying that the sliding is happening. So chances is that, in the question you might assume that it is a pure rolling motion, and for pure rolling motion the I center will be lying at point of contact. So almost option B was almost 50% correct, and the other three options are not at all matching with the given situation. So option B is the right answer. D is discarded because D is incorrect. It is for curvilinear motion. Okay. Next, moving to next question. The cylinder shown below rolls without slipping. In which direction does the friction force acts? The cylinder is shown in figure and it is rolling without slipping. And in which direction the friction force acts? Towards which of the following points is the acceleration of point A on the cylinder is directed? So here the acceleration of point A, to which side it is directed, as it is undergoing rolling motion. Okay, rolling without slipping. So at the point A, if you observe for pure rolling motion, at the point A there will be acceleration that is responsible for acceleration that is responsible for translation, which is ACM, which is r times of alpha. Okay, and there will be tangential acceleration. So tangential acceleration as it is rolling without slipping, and the direction of velocity is given like this, which means the disk has to rotate in the counterclockwise. So tangential acceleration will be opposing this. All right. So now the ACM is R alpha and tangential acceleration is R alpha. So these two are going to nullify and we will be left out with only one component of acceleration, and that is directed towards the center of mass of the disk. And that is radial acceleration will only be there at the point of contact. That is, the acceleration is of the point A on the cylinder is directed towards geometric center. So option B is the answer. Moving to next question. The stone of mass m at the end of the string of length L is whirled in a vertical plane at constant speed. The tension in the string will be maximum when the stone is dashed. So here you are tying a stone to a thread and this is being rotated, okay, at a constant speed. The tension in the string will be maximum. So here the weight will be there, mg, and due to rotation there will be mv square by r. So on the top when it goes, mg and mvr square will be opposing each other. So at the bottom the tension is going to be summation of these two forces, that is weight of the stone as well as along with that centrifugal force is also included. So that is at the bottom of the circle, that is option D is the answer for this case. Okay, moving to next question. A ball A of mass m falls under gravity from the height h and strikes another ball B of mass m which is supported on the rest which is supported at rest on the spring of stiffness k. Assume perfect elastic impact. Immediately after the impact, the velocity is dash. So here it says that the ball A is falling under the influence of gravity from the height h and it is striking the ball B which is supported at rest on the spring. So when the collision is perfectly elastic, immediately after the impact, there will be exchange of velocities. So if there is exchange of velocities, so A is going to give the same velocity to the point B. So if the perfect elastic impact is there, then initially the velocity of B was 0 and now the velocity of A will become 0. Okay, so if you recheck with the coefficient of restitution, that is VB minus VA divided by U, that is initial velocity or velocity of the ball, initial velocity of B minus initial velocity of A. So if this is kept as 1 and the velocity of B will be initial velocity is 0, okay, and VA is non-zero, okay, and finally VA will be becoming 0 and that's how the ratio will be equal to 1. Okay, that is how that's what happens in the elastic collision. So option B is the answer. Next, a wheel of mass m and radius r is accelerated rolling motion without slip under the steady axial torque tau. If the coefficient of kinetic friction is mu, the friction force from the ground on the wheel is dash. So here let me just draw the diagram. So in case of rolling motion, so this disc is accelerating and let's say the disc is rolling towards left side and this will be the inertia force, that is MA. So A here will be equal to R times of alpha because of pure rolling condition, and there will be a friction force accompanying at the interface, that is F. Along with this, the weight is going to act downwards and the torque T is being applied on it. So this value of torque is equal to how much, that needs to be computed. So if we go for equilibrium of forces, that is summation of forces in the x direction, that is equal to 0. So this will be friction force is equal to m times of A it is. Same way, if I take the moments about the center of mass or the point O, okay, so in that case it will be So moments about O, if it is taken, so that is T minus, that is friction force into R is equal to I times of alpha. Alpha is to be written. So T is equal to friction force is mass into acceleration, that is I alpha. So I is mr square into alpha plus F into F is small f is m into A, which is equal to m times of R into alpha, and this will be mr square alpha plus this will be also mr square alpha. So here we get torque as equal to 2 times of mr square alpha. So now this the friction force needs to be calculated. So once we substitute here, that is friction force is equal to, that is from here the alpha can be found out. So alpha will be equal to, that is T by 2 times of m into r square, that is alpha. So substituting the value of alpha in the f, small f, that is equal to m into r, and alpha is T by 2 times of mr square. So r and r will be cancelled, m and m will be cancelled. So this will be T by 2 times of r will be the friction force. So as per the question, the option D is the answer, as none of the options are matching. Okay. In this question, it says about the car moving with uniform acceleration covers 450 meters with 5 seconds interval, and in the second duration, it is covering 700 meters in next 5 seconds. The acceleration of the car is dash. So this question is related to straightforward usage of equations of motion, that is S is equal to ut plus half at square. So for first 450 meters, that is 450 equal to, this is time t is 5 seconds. So 5 into u plus half into acceleration is to be computed, and that is t is 5 square. So this will be 450 minus equal to 5u plus, this is 1 by 2 times of 5 square, that is 12.5 times of a it is. So this will be equation A. And in the second case, let's say velocity will not be same. So that is when it is covering 700 meters in a time span of 5 seconds, but the velocity will be instead v, and this is same acceleration is there. So that is 12.5 times of a it will be, or if you substitute 1 by 2 times of a into 5 square, though that will be 12.5 times of a it is. So if you take the differences between these two, this is equal to 700 minus 450, that is 250. This is 250, and this will be 12.5 and 12.5 a will get cancelled, and this will be, that is minus v plus u, which is v minus u into 5. So this will be v minus u is equal to 50, it is 5 by 250, sorry 250 by 5, which is equal to 50. So acceleration will be equal to v minus u by t. So it is accelerating for the time duration. If we try to calculate, acceleration is actually slope. So for the first, if we try to plot the graph, that is v against time, this is having this will be for first 5 seconds, and for the next 5 seconds, this is how the acceleration is increasing. Okay, so this velocities we are capturing it for a duration of 5 seconds only. That is, the v minus u is already 50 and the time is 5. So this is equal to 10 meter per second. It is 10 meter per second square. That is option D is the answer. Okay. In the question, it says about steel wheel of 600 mm diameter is on the horizontal steel rail. It carries a load of 500 newtons. The coefficient of rolling resistance is 0.3. The force in Newton necessary to roll the wheel along the rail is dash. So here in rolling resistance, there will be some contact. There will be some contact between the horizontal surface and the wheel. Okay, so it will be for some duration or if I redraw the diagram, so there will be, let's consider some surface like this, okay, in which the wheel is being kept and this wheel is being rolled. So when it is rolled, the point of contact will be shifting. The point of contact will be shifting from the which is lying on exactly on the diameter, or which is on the vertical line, it will be shifting somewhere here. So this contact will induce the normal reaction. Okay, let's say when the contact is shifting over here, and the weight will be placed over here, and there will be a force that is going to act in the horizontal direction. Okay, so if we take the moments, let's say this is the point O. If the moments is taken about the point O, that is equal to 0. So now from O to, let's say this is the point P, okay, or let's say this is the point C, this is the center of mass, let's say this is O dash, okay, and this is the force P. Now if you take the moments about the point O, this will be P into the perpendicular distance. The force need not be horizontal, even if it is perpendicular to the radius, so even then the rolling is likely to happen. Okay, so that is P into R is equal to W into the perpendicular distance from the point of contact up till where the weight is passing will be the rolling resistance, that is 0.3. So let's say this is distance A, that is W into A it will be. The force necessary to roll is dash. So P will be equal to W into A. A is the rolling resistance divided by radius it is. So W here is equal to 500 into A will be equal to 0.3 divided by R is 300 mm. Okay, so this is 300. So this will be equal to 0 and 0 is cancelled, and this is 3. This will be 3 ones, and this is 3.1s, and 5 into 0.1 is 0.5 Newton will be the force that is required to roll. Option A is the answer. Moving to next question, the ratio of tension on the tight side to that on the slack side in the flat belt drive is dash. So T1 by T2 is straight away equal to e power of mu theta, that is proportional to lap of the angle proportional to coefficient of friction. So no, it is exponential function of product of coefficient of friction and the lap angle, that is option B is the answer. Moving to next question, a spring scale indicates a tension T in the right hand cable of the pulley system shown in the figure. Neglecting the mass of the pulleys and ignoring the friction between the cable and the pulleys, the mass is dash. So mass here needs to be calculated. So here if you draw the free body diagram, there is a tension, there is a 2 times of tension over here, there is a tension on other side, and this will be mg. So here 4T is equal to mg it is. Okay, and what is need to be calculated? Mass needs to be calculated. So m is equal to 4T by g it will be, that is 4T by g. Option C is the answer. Okay, next is, friction between the pulleys is being ignored. So e power mu theta will not be there, okay, which was included here in the option B. Okay, so option C was the answer. In the next question, AB and CD are two uniform and identical bars of mass 10 kg as shown in figure. The hinges at A and B are frictionless, okay, and the assembly is released from the rest and the motion occurs in the vertical plane. At an instant when the hinge B passes through the point B, the angle between the two bars. So when it is released, the same orientation of B will be there as it passes through the point B. So the angle between these two bars, if this is 60, this will be with vertical, the bar is making 60 degrees, and with horizontal, it is going to make an angle of 60 degrees. Okay, if it is making if the bar DC is making an angle of 30 degrees with vertical, the same bar will make an angle of 60 degrees with horizontal. So if that is the case, when you release it, the orientation of the bar will be same and the angle subtended between the bars will be 60 degrees. Moving to next question. A rod of length 1 meter is sliding in the corner as shown in the figure. At an instant when the rod makes an angle of 60 degrees with horizontal plane, the velocity of point A on the rod is 1 meter per second and the angular velocity of the rod at this instant is dash. So at A the velocity is 1 meter per second. So if we mark the eye center, so velocity of A will be vertical and velocity of B is going to be towards right side. So if you draw the perpendiculars, this is where they intersect. This will be eye center and VA is equal to IA times of omega, and VA is 1 meter and IA is to be calculated. IA will be equal to AB cos 60, it is AB cos 60, which is 1 cos 60, and omega is to be calculated. So this is omega equal to, this is 1 by 2, on other side if we shift it will be 2 radian per second. That is option A is the answer. In the next question, match the 4 correct pairs between list 1 and list 2. No credit will be given for partially correct matching. List A is going to tell us about collision of particles, stability, satellite motion, spinning top, and list 2 is telling us about Euler's equation of motion, minimum kinetic energy, minimum potential energy, impulse momentum, and conservation of momentum. So here this is actually A, dear students, this will be A. Okay, so A will be collision of particles. Collision of particles is associated with impulse momentum, that is A4. Okay, next is B3, that is with stability minimum potential energy principle is being applied, so that is B3. Next is C, that is satellite motion. Satellite motion is associated with the Euler's equation of motion, that is C1. A4, B3, C1, and D is spinning of top. Spinning of top is associated with conservation of moment of momentum. Okay, that is D5 it is. So A4, B3, C1, D5 is the correct combination. Next one, a mass of 35 kgs is suspended from a weightless bar AB, which is supported by a cable CB and a pin at A as shown in the figure. The pin reactions at A on the bar AB are dash. So mass of 35 kgs is suspended. So from here 35 kgs is being suspended, and that is 35, or weight is equal to 35 into 9.81 it would be, and this is being suspended, and we need to calculate what is the reactions at the hinge, pin reactions at the hinge. So here basically the weight will be there, that is T will be there, and along with that the T and another force, that is tension, and let's say this is some angle theta, and the vertical component will be there and horizontal component will be there for the weight, for the tension, and along with that there will be also a reaction due to hinge. Okay, there will be a reaction due to hinge, and that needs to be calculated. So if I draw the free body diagram of the bar, that is at the bar there will be a weight, let's say this is Rx, Ry, okay, and next will be the tension T, this will be T sin theta, and this will be T cos theta. Okay, T sin theta and T cos theta, and along with that weight is also there. So equilibrium of forces in the x and y direction is required to be done, and along with that moment of forces also needs to be taken. So moments about the hinge O, it is equal to 0. So here there is a weight W at a distance of 275. So that is W into 275 W into 275, and this is minus of t sine alpha, t sine theta into perpendicular distance, that will be, perpendicular distance is same as 275. Okay, so t sine theta is equal to W it is. So T will be equal to W by sine theta, that is 350 into 9.81, sorry, it is 35, not 350, that is 35 into 9.81 into sine of the angle. Sine theta will be equal to, this is tan theta will be 125 by 275, and sine theta will be approximately equal to, yeah, so this is theta is equal to 24.45 degrees, 24.45 degrees, that is the value of theta. So this is T will be equal to 35 into 9.81 divided by sine of 24.45 degrees. So this, upon calculation, the value, this will be close to 350 or 360, and sine 30 is 1 by 2. So this is 350 by 0.5 approximately, will be 700 or 755, somewhere in between. So the value of T is T sine theta, that is value of T will be equal to 700 or 800, sorry, it's 829 approximately. And the reaction forces needs to be calculated. So Rx will be equal to, that is T cosine of 24.45, and Ry will be 0, as T sine theta and weight will be cancelling out, as weight and, yeah, T sine theta and weight will be cancelling out. So this comes out to be as 829.7 into cosine of 24.45, which is equal to 755.4 newtons, and Ry will be equal to 0, because T sine theta minus W it is. So these two will be cancelling out. So option D is the answer. Okay. Next is, as shown in the figure, a person A is standing at the center of rotating platform facing the person B, who is riding the bicycle. B is riding the bicycle and heading towards east. The relevant speeds and distances are shown in the given figure. A bicycle heading east at an instant, considering what is the apparent velocity of B with respect to A. Apparent velocity of B with respect to A needs to be calculated. So velocity of B with respect to A it is. So here B is moving with 8 meter per second minus, and the person is standing on the rotating disc, which is moving with 1 radian per second, and the radial position of B is 5 meters from A. So B 8 minus of minus, the radial position is 5 into omega. So this will be minus of minus, which is 8 plus 5, which is equal to 13 meter per second. It will be 13 meter per second. That will be the velocity. That is option D is the answer.